Hi, this video aims at demonstrating the case studies presented in the paper submitted to TACAS. The case studies are based on an application called TeleAssistance TA, a distributed system for remote assistance of patients. We conducted two case studies. The first one regards reachability property verification, and the second one regards model-based testing. We used, for both of them, the model shown in this screen. This is the model of the TeleAssistance system. In the first case study, we are interested in checking the following properties. R1, the probability of succeeding using the device, no failure occurs, is greater than 0.7. And R2, the probability of a failure after sending an alarm occurring is less than 0.06. For them, we have initially to annotate the model with probability of execution. To do that, we construct initially another model of the TA, which is shown here, which is similar to the first one, but has more than 200 states. With this model, we could generate a bag of 5,000 traces using the trace generator plugin. So we click here and we click in generate traces. It opens this new screen where we can insert the number of traces that we are interested in and the generation time, which is the interval time in which each trace will be produced. In that case, we can leave it blank. So after doing this, we save the traces in a file, and we can now import that traces to this model. To do this, we use the model probabilistic annotator plugin, in which we can select the component which we want to annotate. In that case, it's the TeleAssistance, and the source of probability, which is this file. We save and we start. Then we can see that the probabilities have been annotated in the model transitions. The result of this process is a PLTS, and with this PLTS we can now conduct some property verification. To do this, we click in the verification menu, and after in the probabilistic reachability submenu. Here we can inform the source state and the target state and the condition that we want to compare to. In that case, for first property, we are interested in the probability of succeeding using the device is greater than 0.7. This is the probability of reaching state 2, which represents a successful use of the device. So we want the probability of from state 0 reaching state 2. It has to be greater than 0.7. We calculate it, and it means that it's true. So if we take this off, we can see the real value of the property. The second property, the probability of a failure after sending an alarm occurring as less than 0.06, is calculated by finding all paths that reach the state 5, which is the stage corresponding to a failure after sending an alarm. So we put the 5 here, and then it has to be less than 0.06. We calculate and it says false, If we want to see the real value, it is this value, so this is false. If we want to verify whether our analysis is correct, we can export the model to Prism, save this model as a Prism model, and in Prism we can open the model, and then we can verify the same properties that we used in LoTuS. So the property area means the property has to be greater than 0.7, and the property is true to x equals 5, and we can add another property which represents property area 2, 0.06, true to x equals 5. I'm sorry, the first one is x equals 2. So the first one means a successful and it's true, as we the same result that we found in LoTuS. And the second one, it's false, so our analysis using LoTuS are correct. The second case study regards model-based testing. To do this, we used the TCG plugin, which allows us to generate abstract test case from the model. We can use different algorithms for generation, and as we used in the paper, we used the all paths algorithm. Then first of all, we can submit and see that we generated 308 paths, but this is a very large number of test cases, so we can refine this generation using selection criteria, which is in this case the similarity of paths, in which we use a degree of similarity, which is 25, so it will return the test case, only 25% of the test case. So submitting, we see that now we have just 95 states, 95 test cases. If you click here, LoTuS shows which are the test cases. Finally, we can still refine even more the selection using a test purpose. In this case, we're going to select only the test case in which we have a failed alarm. So we can put failed alarm here and then submit, and then the new result produces only 30 test cases. So we using this this process, we reduced a lot the number of test cases. So that's it, the case studies and how we produced it.